We have done some balancing before. Let's try to balance some more chemical equations. So we have a given equation, HCl plus K2Cr2O7 gives us KCl plus CrCl3 plus water, that is H2O, plus Cl2. So what are the given atoms that we have? We have H, hydrogen. We have Cl. We have K, potassium. We have Cr, chromium. And we have O, oxygen. So these are the given atoms. Now let's try to count the number of atoms on both the reactant and the product side. So let's start with hydrogen. On the reactant side we have 1 into 1, 1 atom. On the product side we have 2 into 1, 2 atoms. Chlorine, here we have 1 into 1. And on the product side we have 1 into 1, 1 plus 3 plus 2. So 3 plus 1, 4. 4 plus 2, 6. Then we have potassium. Here we have 2 into 1, 2 atoms. And here we have just 1. Chromium. Here we have 2 into 1, 2 atoms. And this side we have 1 into 1, that is 1. Last, oxygen. Here we have 7 into 1, 7 atoms. And on the product side we have 1 into 1, 1 atom. So these are the given number of atoms of the different atoms on both the sides. Now let's write the equation again. So this is the equation. So we start with hydrogen. On the reactant side we have 1 atom. On the product side we have 2 atoms. So now how do we balance this? We can balance this by taking 2 molecules of HCl. So when we take 2 molecules of HCl, we get 2 atoms of hydrogen, 2 atoms of chlorine, and this remains the same. So we have 2 atoms of potassium, 2 atoms of chromium, and 7 atoms of oxygen. On the product side we have not made any change, so the number of atoms remains the same. Okay. So now our hydrogen is balanced. What do we see next? Next we see chlorine atoms. So here on the reactant side we have 2 chlorine atoms. On the product side we have 6 chlorine atoms. So how can we balance chlorine atoms? We have to make this number 6. So we have to use 6 molecules of HCl this side. So we can do that by removing this 2 and using 6 molecules of HCl. So when we use 6 molecules of HCl, we get 6 atoms of hydrogen, 6 atoms of chlorine. This remains the same. And again, no change on the product side. Now, what do we observe? Our hydrogen is now imbalanced again, because while balancing chlorine, the number of hydrogen atoms has increased to 6. There the number of hydrogen atom remains 2. So how can we balance hydrogen? We have to make that number 6. So how can we do that? We can do that by multiplying this water molecules by 3. So when we multiply this by 3, we get 6 hydrogen atoms. Now we have 3 ones are 3, plus 1 4, plus 2 6. Chlorine is 6. Potassium is 1. Chromium is 1. And oxygen atoms has now changed. So this becomes 3. On the reactant side we have not made any change. So this remains the same. Now if you look at the equation, hydrogen is balanced, chlorine is balanced. Now our potassium and chromium atoms are not balanced. Over here we see 2 atoms, here we see 1 atom. So we can balance both simultaneously. So let's put a 2 before both. So when we do that, our hydrogen, we have not changed. This remains 6. Chlorine we have changed. It becomes 6 plus 2 plus 2. So it becomes 6 plus 2, 8 plus 2, 10. Potassium becomes 2 into 1, 2. Chromium becomes 2. And oxygen remains 6. Oxygen remains 3. On the reactant side, we have not made any change. So these numbers remain the same. Now, if you look at the equation, we have changed our chlorine atoms. On the reactant side, we have 6 chlorine atoms. On the product side, we have 10. So how can we make the chlorine atoms even on both the sides? We can do that by making this number 10. So if we take 10 molecules of HCl, we get 10 atoms of hydrogen, 10 atoms of chlorine, and these numbers we have not changed. Similarly, there is no change on the product side. So these numbers remain the same. Okay. So now we have balanced our chlorine. But again, hydrogen is not balanced now. How can we balance hydrogen? Here we have 10, that side we have 6 atoms. So we can balance hydrogen by not using 3 but 5 molecules of water. So when we use 5 molecules, we have 10 hydrogen atoms. Chlorine remains the same. We have not changed it. This remains 10. Potassium is 2. Chromium is 2. And now our oxygen atoms become 5. We have not changed anything on the reactant side. So this remains the same. Alright, so now our hydrogen is balanced, chlorine is balanced, potassium is balanced, chromium is balanced. But our oxygen atoms are not balanced. Here we have 7, that side we have 5. How do we balance this? We have to make this 7. So to get oxygen 7, so we have to make this number 7. When we make this number 7, that is we take 7 molecules of water, we get 7 atoms of oxygen. Let's look at the remaining things. Hydrogen becomes 14 now. Chlorine atoms we have not changed. So these numbers remain the same. And similarly, no change on the reactant side. So now our oxygen atoms are balanced. Chromium is balanced, potassium and chlorine is balanced. But again, our hydrogen atoms are not balanced. To make this 14, we have to make this 14. So we have to take 14 molecules of HCl. So when we make this 14, we get 14 atoms of hydrogen, 14 atoms of chlorine, and these remain the same. No change on the product side. So these numbers remain the same. Now if we look at the equation, hydrogen balanced, potassium balanced, chromium balanced, oxygen balanced. But chlorine is not balanced. We need 14 atoms there. To make that 14, we can change this chlorine atoms, these chlorine atoms or this. If we change the number here or here, we know we also change the number of potassium and chromium atoms. So again we have to start the balancing. So what do? We change this number, because that will not change any number of potassium or chromium atoms. So to get 14, we already have 6 plus 2, 8. So we need another 6 atoms. So we multiply this number by 3. So when we multiply this by 3, we get 3 2s are 6, plus 2, 8, plus 6, 14. So we get 14 chlorine atoms. We get 14. This number we have not changed. So the remaining numbers remain the same. And similarly, we have not changed anything on the reactant side. So they remain the same. So if we now look at our equation, hydrogen atoms are balanced, Chlorine atoms are balanced, potassium atoms are balanced, chromium balanced, and oxygen balanced. So we got a balanced chemical equation. But isn't it a tedious process? We had to use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps. So this looks like a tedious process. How can we make this easier or shorten the process? Let's use a trick. This is our given equation. So the trick is, the species which is sitting alone, let's not disturb that. We'll balance that in the end. So let's write our atoms. Since we'll balance chlorine in the end, because this is sitting alone, so let's start balancing this first. Because let's leave this for the end. So let's move this here. So now if we write the atoms, we get K, Cr, O, H and Cl. So we'll balance chlorine in the end. Let's count the number of atoms again. Potassium 2, chromium 2, oxygen 7, hydrogen and chlorine 1, 1. On the product side, potassium 1, chromium 1, oxygen is 1, hydrogen is 2, and chlorine is 3 plus 1, 4 plus 2, 6. Now let's balance potassium and chromium first, because we see two atoms both on this side and we see only one atom on the other side. So let's multiply this by 2. So when we take two molecules of these two molecules, so we get two atoms of potassium, two atoms of chromium, oxygen remains 1, hydrogen remains 2, and we have changed our chlorine atoms. They now become 6 plus 2, 8 plus 2, 10. And on the reactant side, we have not made any change. So these numbers remain the same. So now these two are balanced. Oxygen atoms here are 7, there 1. So now let's balance oxygen. So we can balance oxygen by taking 7 molecules of water. By doing this, we get 2 atoms of potassium, 2 atoms of chromium, 7 atoms of oxygen, 14 atoms of hydrogen, and chlorine remains the same, that is 6 plus 2 plus 2, which is 10. No change on the reactant side. Now these three are balanced. Let's balance hydrogen. Here we have only one atom, that side 14. So how can we balance this? We take 14 molecules of HCl. So when we take 14 molecules of HCl, we get, this remains the same. Since we have not changed potassium, chromium and oxygen, hydrogen atoms now become 14 and chlorine atoms now become 14. No change on the product side. So you see that now potassium is balanced, chromium is balanced, oxygen balanced, hydrogen balanced, but chlorine is not balanced. On the reactant side we have 14 atoms, on the product side we have 10 atoms. So now to balance chlorine, we will not change this number, because here if we change this number, potassium atoms will also change. We cannot change this number, because if we change this number, chromium atoms will also change. So we know that we can only add a number here, because this species is present alone. Adding a number here will not change the number of atoms of any other element. So how do we balance chlorine? On this side we have 14 atoms, that side we have 10 atoms. So we already have 3 2s are 6, 7, 8 here. So we need additional 6 atoms of chlorine. So we get 3 molecules of chlorine. So when we make this 3, now we have 3 2s are 6, plus 2, 8, plus 6, 14 atoms of chlorine. So by making 3 molecules of chlorine, We now have 14 molecules of chlorine, and we have the same number of all these atoms, as we have not changed them. Similarly, we have not changed anything on the reactant side, so this remains the same. So now, if you look at the equation, all our atoms are balanced. So this is our balanced chemical equation, and this you see, by using only 5 steps, we were able to balance the equation. Last time we had used 10 steps to balance the equation. So what do we see here? When we balance the species sitting alone in the end, we reduce the number of steps. So we remember that whenever any species is present alone, always balance it in the end. Let's take another example here. We have a given equation MnO2 plus HCl gives MnCl2 plus water plus chlorine. So which out of these 4 is the balanced chemical equation for the given skeleton equation? Let's try to balance this equation. Let's write the atoms which are present. We have manganese, we have oxygen, we have hydrogen and chlorine. So these are the 4 different atoms that we have. Now let's write the number of atoms on both the reactant and the product side. So for manganese we have 1 atom, oxygen 2 into 1, 2, hydrogen 1, chlorine 1. On the product side we have 1 manganese, oxygen is 1 into 1, 1, hydrogen is 2 into 1, 2, and chlorine is 2 plus 2, 4. So we see chlorine is sitting alone, that is, it's a species present alone, so we will balance it in the end. So now, let's write the given equation. So now we see that there are 2 atoms of oxygen on the reactant side, 1 atom on the product side. So to balance oxygen, we have to make this species 2. Let's make it 2. So when we make this 2, what do we get on the product side? We have 1 manganese, we have 2 oxygen, we have 2 2s are 4 hydrogen, and chlorine is 4. We have not made any change on the reactant side, so this remains the same. Now if you look at the equation, manganese and oxygen is balanced, hydrogen is not balanced. So how do we balance hydrogen? We have to make this number of atoms, that is 1 atom on the reactant side, we have to get this 4 atoms. So we can get this 4 by taking 4 molecules of HCl. So when we take 4 molecules of HCl, our manganese remains the same, oxygen also remains the same, but now we have 4 atoms of hydrogen and 4 atoms of chlorine. We have not made any change on the product side, so this remains the same. So now if we look at our equation, manganese is balanced, oxygen is balanced, hydrogen is balanced, and chlorine is balanced. So by always balancing the species which is present alone in the end, we are able to reduce the number of steps, and it becomes a really easy process to balance the equation. So we'll always remember that whenever any species is present alone, we always balance it in the end. This is our trick 1.